Hi, it's Werner again. In the last video on alkalines, we looked at a no-name AAA battery with a 5.1 ohm constant resistive discharge. Today we're going to look at the same discharge on a high-energy Varta battery and also look at how it behaves under pulsed load conditions. As you may remember, we got about 2 hours and 40 minutes of runtime out of the no-name battery and also saw some recovery effect after disconnecting the load. As we can see up here, we have 667 milliwatt hours of total energy that we extracted from that battery. Discharging the brand name battery the same way, we instead get 4 hours and 10 minutes of runtime, and we extracted close to a milliwatt hour of energy, 991 milliwatt hours. We also see the same recovery effect that the no-name battery exhibited when we turn the load off. We let the battery rest for a few hours, and we're going to run this test again and see if we have any residual energy left. As we can see, the discharge curve looks similar, but the voltage drops much faster than the initial discharge, reaching the cutoff voltage here in just 30 minutes. Still, this yields almost 80 milliwatt hours of energy, and if we repeat this again and again, we can see that there's diminishing returns from 79 to 20 to 14.9 milliwatt hours. The problem here is that when you discharge an alkaline battery at a high rate, the chemistry just can't keep up. Let's move on to a new fresh battery of the same type, keeping the same load, but this time we only let the load be active 1/3 of the time. So this is how the result looks like when we're pulsing the load instead. If we zoom in to the individual pulses, we can see that it's active 1/3 and idling 2/3 of the time. We now take 13 hours and 50 minutes before we reach the voltage cutoff, and we have extracted 1.24 watt hours of energy, which is 25% more than with the constant drain. The main reason here is we are giving the chemistry more time to redistribute the charges. In order to maximize the life of an alkaline cell, it's important to keep the average current consumption as low as possible to avoid an early voltage cutoff. That's it for today. If you like this video, subscribe to our channel.